talk is about thinking from a client side, how to use APIs, especially the third parties outside of the companies managed by external vendors, how to build integration, how to maintain it. First of all, my name is ZQ. I have worked in Stripe API platform teams for almost 3 years, and I was in the team when the team was only like 3 or 4 people. And then I joined Nylas, working on API platform again, basically designing the new version and like managing them. So I have worked on vendors a lot, and I have worked on integrating with other people's API a lot too. So this is some knowledge sharing on what are good API, what are bad, and what is the difficulties when we are handling them. So the agenda is I'll do some introductions on like why do we need third-party APIs and like build versus buy questions. What are the challenges you have to keep in mind? How to select the best ones, or how to manage it, monitor it, how to handle failures from those APIs to ensure long-term success. And then we'll do some case studies. Let's take a step back and think about why those API exist, or why API exists at the first place. Imagine you are a car company, you're building a car factory right now in like 2024. You probably don't want to build everything from scratch. And you don't have to build seats, dashboard, tires, wheels, and everything. You probably have to buy parts from other vendors. There's already a supply chain well managed for car industry that will make sure it can respond to inventory management or the transportation of it. The same goes with our industry. Probably like 20 years ago, when Google starts, they probably had to host their server. I remember about 8 years ago when I worked with a company that had to rent a room and put all their servers in there, and they pay the air conditioning bills. They even have like small fans blowing wind in their server rack to make it cool. That thing doesn't happen anymore right now. There's AWS for everything, and the same goes with API. If your company is doing authentication, authorizations, you probably go to Okta. You want to send SMS message, you go to Twilio. Same with payment with Stripe, and email calendar integration with Nylas. I don't want to like list all like good and bad on the APIs. Rather, we can look at a theoretical payment API. By the way, this API is not Stripe API. So the host is not Stripe.com. Let's imagine there's a payment API that you swipe a credit card, and it is a post. You put credit card information there, expiration, CVV, and it's /charge, and it give you a response and says, okay, this card is swiped. That's great, right? What's missing here? The first thing missing is authentication. Right now in this example, there's no authentication showing here. So if a company doesn't put authentication first, maybe it's not a good vendor. People treat authentication like quite differently in how to accept it. Even Stripe, they used to support putting API keys as a query parameter. And this sometimes can cause troubles because the client can sometimes accidentally log the entire URL and put it in a logging vendor like Splunk or CoreLogic or New Relic, whatever, and accidentally leaking the API key. This is not a really good way of authentication. Some others allow you to create a username and password, and sometimes people put API key as username or password. This is secure, like over SSL, as long as it is encrypted. But there are some other ways too. You can put it in barrier token. It's the same header, it's just a different format. I'm not going too deep on how OAuth2 works, but basically if the third-party vendor allows you to use some other authentication vendors like Okta or Google, Facebook, you can log into their website, and then they will like give you access token. This is usually expiring every hour, so it's pretty safe even if it got leaked. It won't cause too much trouble in the long term. What if my API key got leaked? If a vendor doesn't provide a way to rotate the key or revoke the key within minutes, then it's probably not a good vendor. So this is a Nylas page. If you find the key is leaked to hackers, just click and revoke it and create new keys. Let's return to our example API and add authentication here. So there is still one thing missing about the API design from the vendor, which is the second most important thing, versioning. From this API, from the shape of it, it doesn't tell you which version it is on. And if a vendor tells you that all our changes are backward compatible, they are definitely lying. There are several ways in the industry to manage API versioning. The first is the version in the URL. Nylas, we do that. Stripe, they have that V1 always, but it's not the real version. The real version is in headers. So you have to pass the API version and the real version to Stripe, and they will return you with the correct format. Then what if people don't pass those headers? Usually, the vendors will default you to the latest version when you register your application. In this example, like the current version is basically the version you are on when you start your app. And even if you don't pass the headers, you'll just use that version. It's called implicit versioning. And if implicit versioning, you want to change it, you want to upgrade it, then the vendor must provide such a page that tells you what format got changed. Is there any request field that got removed or got renamed? For response, there's a field no longer supported. The third important thing is how to handle errors. So let's say our theoretical API, they return 500 with internal server error. I have seen that actually from Microsoft Graph API. So sometimes when you pass some query parameters in the wrong way, it will end up breaking out the entire, probably resulting in a null pointer in their backend. But showing such message is not helpful. It doesn't tell you whether I can retry it or is my request in the wrong format or what. So the world-class API, they handle the errors transparently, and they show you what exactly is going wrong, and they will point you to the right documentation. They give you a way to share that specific request to their customer support, to their community page. And then it should provide you some developer dashboard so that you can debug yourself. This is a really good example of how to show the error response. In the response, there's a request ID. You can grab this ID, talk to the customer support. And then there are error types. And I probably search this type and find an answer from Google or ChatGPT. There's a doc link. You can click and see how to avoid such error. And the error message is really clear. It tells you the card number is not valid. This is the developer page from Stripe. Post V1 charges, it will show you all those useful information like status, the request ID, time you made the request, IP address, the source of it is from the browser, item policy key is the origin header value, and what exactly is missing. The fourth thing to look out is a rate limit. API usually have a rate limit, and if you are being rate limited, the status code is usually 429 and tell you, okay, please slow down. We're having trouble processing your request. So how to handle this from client? First thing is to gather more information, even if it is not being rate limited at the first place. So look at the bottom right section here. So those are 3 example headers. Sometimes the server will return you. So sometimes the server will tell you the rate limit is 100 over a time window of 1 minute. That means you can have at most 100 requests over 60 seconds. And it tells you how much requests you have remains in that time window and give you a time where you can retry safely. Not every API is supporting it, but if a vendor is supporting it, it's a good API. You can also use the thread pool or queue your request so that it doesn't have a burst of traffic check with the vendor whether they support batch API and how they limit their batch. For example, Google Gmail API, they have a really hard limit on their messages, like get message, get threads. Even if you are passing them in a batch, they are still calculating based on the batch size and limit you. Even if you are just making one batch request, there are too many of them in one batch, then Google will end up returning you a 429. What if I already controlled everything, but I still got limited? There's one algorithm called like exponential backlog retry. If a request got limited, wait 2 seconds, then 4 seconds, 8 seconds, 16 seconds. But there's one problem doing that. And if there's a burst of traffic, I mean thousands of requests, and are all waiting at 2 second timestamp and then like 4 seconds, that means the burst will happen again, hammering the server. This is called a thundering herd effect. Try to introduce some randomness, some jittering, so that some requests will wait 1.8 seconds, some requests will wait for 2.2 seconds, so that it will spread out the burst. And finally, item policy. A lot of requests, retrying it doesn't make sense. For example, you are swiping a card, and it tells you, okay, you got limited, or the request doesn't go through. Or what if internally they're already halfway through processing your credit card? Then if you retry it, it end up like double charging customers. Same goes with sending text messages or email. If you have these retries and every retry fails, then people will receive hundreds of emails for no reason. So check with the vendor whether they provide idempotency. It's usually controlled by idempotency key in the header. So when you retry, make sure you're using the same idempotency key. So those are the most important things to look out. There are several others too. For example, the security and privacy. Even if you are in compliance with security and privacy, as long as you are using some other third-party API, they have to be in the same compliance as you. Otherwise, your customers will probably have a way to see you are suddenly out of compliance. You can also look out SDKs provided by the vendor. Check if their SDKs are open source in GitHub. If it is open source, for client, it's way easier for debugging. Is there any reasonable and scalable pricing plan? Like Stripe, they charge by transaction fee. For Nylas, we charge by number of accounts. Check their billing to avoid surprising bill, and check the level of support. Some vendors even provide shared Slack channels. They have a SLA of resolving your problem. Check their SLAs and SLOs on their API too, the latency, availability, commitment, and then try to consider building the API yourself. And sometimes for your specific use case, it's probably easier or cheaper to build it yourself. How to manage API on the client side? Never trust what vendors say. They may change their API format shape and forget to tell you. They may suddenly run out of availability. So try to monitor it, try to document it, try to avoid sending user data, redact them, or if you are sending it, make sure they are in compliance, and check the regulations, GDPR, CCPA, HIPAA. We can look at our API and give you an example, a good API. We have a trust center, and they list all the compliance we follow. See the GDPR, IPA, the PCI, everything is there. We have a status page. Every time an API went down, the first thing we change is this page. Our versioning is controlled in URL paths. We don't support headers. The authentication is barrier token. We support both API key and access token, OAuth. In the response, we always return request ID so that you can tell you which request is wrong. We'll just look it up in log. Our SDKs are both documented and open source. We do have a support page. We also have shared Slack channels. Every time people have trouble using the API, we create a ticket on our side and reach out to you. And we do have a lot of happy customers. This is from myself. This is a build versus buy argument. So if they do not use our API, they'll probably need to hire 10 full-time engineers working several months to integrate with Microsoft Exchange. Another customer is Nylas. It's easier for them to just use the third-party vendor, and it's pretty well designed, easy to manage. All right, I think that's a presentation. We can go to the Q&A.